Alright, hello everybody, welcome back. Today we're gonna be proving some trigonometric identities. Not all of them. I know I said I'm not gonna, but yeah, I had a diagram drawn because first time I was recording this, it just messed up everything. But yeah, so we're just gonna prove the sum angle, difference angle thingamajigs for sine and cosine. I didn't do it for tangent because you just need to know sine and cosine, then you can represent everything else in the terms of those. So yeah. So to prove all four of the sum angles and difference angle or whatever, you need to have this diagram. I don't know how some genius crazy person came up with this, but they thought that, hey, what if we did these totally random things, and they came up with it. So yeah. But we have an advantage because we know the sum angles and those things, so we have direction. We know what way we're trying to go and we know what we're trying to do. Okay, so because this hypotenuse is 1, we have a triangle with 3 triangles in it, and these are the right angles. So then this is also a right angle, but we need to we know that kind of. So yeah, so now this one is length 1. That means that yeah, so then if we know the other angles, we'll be good to go. So this is yeah, so notice that notice that this is not the only triangle with a hypotenuse 1. This one also has hypotenuse 1. So we can notice that this is a cosine of b times the hypotenuse, but hypotenuse is 1. Same thing here, but with sine. Okay, all good. So now what we can do is we can find this length in terms of the sine and cosine of a and b. So this length over here, we don't know what to do, but maybe if we could take the cosine and sine of this angle, we'd find some relation with this sine b because they have a common length. So we take the sine because it's opposite, not adjacent. So the sine of alpha, this A is an alpha, this B is a beta. That's what we call it. So sine of alpha is equal to sine of beta. Over this thingy. We're gonna call this x for now. Okay, and then we know that the cosine of alpha, because that's what we're trying to find here, and that's adjacent to angle alpha. So that's equal to thingy over x. So now what we can do is yeah, so this is also over x, right? Wait. Yeah, okay. So now what we can do is, now this thing is y, let's say. So what's y is this is y. That's what we're trying to find. So we'll put that as y. So now we notice that what we can do is we can say that we can so we can find an expression for x on the top one and substitute it into the bottom one, right? Yeah, okay, so then we multiply by x on both sides of the first one and divide by sine of alpha. We're gonna get x is equal to sine of beta over the sine of alpha. So we now have an expression for x, so we don't need a so we don't need that variable, and we can actually put that here now. We know that this is sine of beta over sine of alpha. Now we can substitute it into this, and we're gonna get y times the sine of alpha over the sine of beta. And hey, now we can multiply by sine of beta over sine of alpha on both sides, and we're gonna get something, an expression of sine and cosines of alpha and beta for y, which is what we're trying to solve. So we multiply by sine of beta over sine of alpha, and we're going to get y is equal to the cosine of alpha times the sine of alpha over the sine, the sine of beta, right? You multiply by sine of beta over sine of beta over sine of alpha, sine of beta, sine of alpha. Okay, cool beans, cool beans. So, yeah, now we can put that in here, and we're gonna have our y, which is nice. I know you think this is taking a while, but we know only one of them will be all good. So, I haven't told you what identity we're trying to prove. We're actually trying to prove the sum angle for sine. So sine of so we're trying to do sine of alpha plus beta. So now you might be wondering, but beta and alpha on the opposite sides of the triangle. How are you going to use that? Well, wait and find out. You'll see. It's gonna be great. So now, so now what we can do is we can look at these angles, right? And then so now this angle over here. What is that angle? Well, because this is a right triangle, then that means that this is 90 minus alpha. We can actually do the same thing here. This is 90 minus beta. So that means that this angle is alpha plus beta. Oh my god, what a coincidence. That's so cool. So now, we want to find the sine of alpha plus beta. We can find the cosine too, but I'd rather go with sine. So the sine of alpha plus beta is opposite over hypotenuse. So it's just this length. Now notice the bigger triangle at hand. And now we notice that is also, so now what we have is a big thing. So this length is sine of alpha plus beta, right? But if you look at the large triangle with the triangles in it, then that's also the sine of alpha. So then, so we look at the sine of alpha. The sine of alpha is not this smaller triangle. We're looking at this bigger triangle. So the sine of alpha is opposite, which is opposite, which is something. In this case, we don't know it. Over the hypotenuse, which is cosine of beta plus cosine of alpha times sine of beta over sine of alpha. So now what we can say is that we can say that sine. So if we so yeah, I'm just gonna write that up. So the cosine of alpha, or sorry, not the cosine, sine of alpha is equal to opposite, which is the sine of alpha plus beta over this whole length, which is adding cosine of beta and cosine of alpha, sine of beta over sine of alpha. So cosine of alpha, right? No, cosine of beta. Okay. Cosine of beta plus cosine of alpha, sine of beta over sine of alpha. Now we're looking for sine of alpha plus beta, not sine of alpha. So we multiply by this thingy on both sides, and we're gonna get the equation for sine of alpha plus beta. So we get the sine of alpha plus beta is equal to sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta over the sine of alpha. We can distribute it, and notice that these two cancel. So we're gonna get the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. And that's our nice expression for the sum angle of sine. So now I'm not gonna do the exact same procedure for the rest. I recommend you try to do it for maybe cosine or something like that. But yeah, what we're gonna do now is we're gonna use that. So hopefully you know the identity that if you don't, it's okay. But the sine oh wait, no, sorry. The sine of 90 minus let's say alpha, or not alpha, let's say x. We already use x. We'll do theta. 90 minus theta equals the cosine of theta. This is because you have the graph of sine and cosine at the same period, amplitude, all that. The sine is gonna be going through like that, and then blah 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 blah. It's just important that it goes through like that. The cosine, on the other hand, goes here. So if you shift this, it's gonna be shifted pi over 2, which is 90 degrees. So this is actually I'll write it as in radians. So pi over 2. So hopefully you've learned about the graphs and all. That was just a quick explanation, but yeah. So what we can do now is that we can say that, okay, what's the cosine of alpha plus beta? So so the cosine of alpha plus beta is just wait, let's do cosine of alpha minus beta first. That's equal to the sine of 90 minus that's equal to okay, so that's equal to the sine of, oh my god, what happened here? Of 90 minus that, which is 90 minus alpha plus beta. But that's equal to the 90 minus alpha plus beta, if you know what I mean. So now we can use the sine of the sum angle thing again, and we're gonna get that that's equal to the sine of 90 minus alpha times the cosine of beta plus the cosine of 90 minus alpha times the sine of beta, which is equal to, this is just a cosine of, actually pi over 2, guys, pi over 2. No 90s here. Pi over 2. Okay, and that's equal to the cosine of alpha times the cosine of beta plus the sine, right? Sine of, oh, by the way, this actually works the other way around if you switch cosine and sine, right? Because the period is whatever. Yeah, so yeah, okay, so now the cosine of, okay, yeah, plus the sine of alpha times the sine of beta. So that's for cosine of alpha minus beta. We can set beta equal to negative beta, I guess, instead, right? So now we can use this to get, we can go there, and then we can also say that the sine of alpha minus beta is equal to the sine of alpha plus negative beta, which is equal to, I'm actually gonna do it down because why not? That's equal to the sine of alpha times the cosine of negative beta plus the cosine of alpha times the sine of negative beta. We know that the cosine of negative beta is just the cosine of beta. So we're gonna have this. And we know that the sine of negative beta is equal to negative sine of beta. So then this negative is gonna go out. The cosine of alpha, sine of beta. There we go. Now last thing is just we're gonna do cosine of a plus b. So now what we're gonna do is we're gonna go from here. We know that if we set beta equal to negative beta, I guess we're gonna get cosine of alpha plus beta. We're doing it the other way around. Is equal to the cosine of alpha minus negative beta. So now we use this, and we're gonna get that's equal to the cosine of alpha times the cosine of negative beta plus the sine of alpha times the sine of negative beta. Cosine of negative beta is just the cosine of beta. And then the sine of negative beta is a negative sine of beta, so the negative goes out. And that's it. We have all 4 of our identities, the main ones. We can use for tangent as well, but you know what? Because I didn't cover it that time, I might as well just cover it now. You don't really need the tangent one, but I mean, here we are. You sometimes need it. You might want to need it if you're in trigonometry class, but yeah, the tangent of alpha plus beta. So that's equal to the sine of alpha plus beta over the cosine of alpha plus beta. Right, and that's all you really need. You can just do this, and then we can think of the expressions, which is sine of alpha. Oh, by the way, you get the double angle identities by setting alpha equal to beta, and boom. So yeah, so sine of alpha, cosine of beta, plus sine of beta, cosine of alpha, over cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. Alright. So now that is equal to that we can set that equal to the tangent of alpha, because we want tangents. So that times the cosine of alpha times the cosine of beta. Notice how the cosine of alpha and cosine of beta kind of, notice how the cosine of alpha and tangent of alpha kind of like go away and become a sine of alpha. But yeah, too bad for us. Times the cosine of beta, and then plus the tangent of beta times the cosine of beta, notice signs, times the cosine of alpha, over the cosine of alpha, beta, minus tangent of alpha, cosine of alpha, tangent of, tangent of beta, sine, or cosine of beta. We kind of just got rid of the signs. That's kind of what we wanted to do. So now, that's equal to, if you can factor it, and we're gonna get the cosine of alpha. Alpha times the cosine of beta. Times, just two, this cos. I don't like cos, I like cosine. That's gonna, and then that times the tangent of alpha times the plus the tangent of beta. All over the cosine of alpha times the cosine of beta times 1 minus the tangent of alpha tangent of beta. These cancel, and then that's our identity. That's equal to tangent of alpha plus the tangent of beta over 1 minus the tangent of alpha tangent of beta. I don't really see why to memorize this, but so don't. But do understand it. You can at least understand this one because you can get it from the others. Basically, the main thing that you should know here when in the proof is that get rid of the signs and set them equal to the tangent times the cosine. And then everything, and then factor and then cancel. So then this is the identity. Notice that tangent of x is equal to the sine of x over cosine of x. So the tangent of, I'm just writing this fast and ugly and sloppy because it's just fast. So tangent of negative x is equal to the sine of negative x over the cosine of negative x, which is equal to negative sine of x over cosine of x, right? Because cosine doesn't get affected by this. It gets affected from pi minus theta, and then sine is opposite. So now this is equal to negative sine of theta, or sine of x over cosine of x, which is equal to negative tangent of x. So just know that. So now we can use that, and then we can find out that. Now I'll leave this as an exercise, but now the tangent of alpha minus beta. Just plug in negative beta, you're gonna get the tangent of alpha. Tangent of negative beta is negative tangent of beta, so we're gonna get tangent of alpha minus tangent of beta over, this becomes, remember, same thing, tangent of negative beta becomes tangent of beta, so then negative goes out, they cancel, become the plus tangent of alpha times the tangent of beta. So just flip the signs, I guess. Just flip the signs when you get this. So yeah, that's it for this video. We have all our 6 identities now. We're not going to do cotangent, secant, and cosecant. I'll leave that as an exercise, and you don't really need them because they're just the reciprocal of sine and cosine and tangent. So yeah, you really need these 4, but occasionally you might as well just have these in your toolkit if it's not big enough. So yeah, thanks for watching. I'll see you guys next time. Goodbye.